Now, this performance of quicksort depends on the relative size of the two sublists that are formed. If the partition is balanced and the two sublists that are formed are of almost equal size, then the sorting is fast. And if partition is unbalanced and one sublist is much larger than the other one, then the sorting is slow. Now, the best case for quicksort will be when for each sublist pivot is placed in the middle of the list. That means each sublist is divided into two almost equal sublists. Now, if we have a list of size n, then it will be divided into two sublists of size approximately n by 2, which will be divided into four sublists of size approximately n by 4, and this will go on till we get n sublists of size 1. Now we know that n elements can be repeatedly divided into half approximately log n times. So after halving the list of n items log n times, we get n sublists of size 1. So the number of comparisons comes out to be this, and this is n log n. So in the best case for quicksort, the performance is n log n. Now let's see what is the worst case for quicksort. If pivot is the smallest or largest element of the list, then we get two sublists from which one is empty and other has n minus 1 elements. And the worst case for quicksort occurs if this happens for every sublist that is formed. And if we take first element as pivot, then this worst case occurs when the list is fully sorted or in reverse sorted order. Now suppose we have a list of n elements, then in worst case we'll get sublist of size 0 and n minus 1, then we'll get sublists of size 0 and n minus 2, and so on, and at the end we'll get sublists of size 0 and 2. This is an example. Here the list is in sorted order and first element is taken as a pivot. So first we get one empty sublist and sublist of size 4. Then we get this empty sublist and sublist of size 3. Then we get this empty sublist and sublist of size 2. So the total number of lists that are sorted is equal to n minus 1. And the size of these sublists are n, n minus 1, n minus 2 and 2. So the total number of comparisons comes out to be this, and this is order of n square. So the performance of quicksort in worst case is order of n square. Now this quicksort is not a stable sort. That means it does not maintain the relative order of duplicate elements in the sorted output, and the space complexity for this sort is order of log n, where n is the number of elements.